Hey there guys, this is Mr. Meiosis, and this is part 2 of my integration by parts video, which is ironic considering it's called integration by parts, and I did my video in parts. Get it? Okay, anyway, let me go and do example number 4. Examples number 4 and 5 are integration by parts problems, but example number 6 is not, but I'm just going to throw it in there as a, an additional problem to look at. So, remember in the last video I talked about this guy right here. And as we look at it, we got algebraic before we've got trig. So our u is going to be x squared. So we take the derivative of that and we get 2x. Our dv is going to be sine of 2x, which makes our v negative 1/2 cosine 2x when we do the antiderivative of that. All right, so I'm going to rewrite this using ultraviolet voodoo, right? So u times v minus the integral of v du 2x dx. I forgot my dx here. All right. Okay. So, let's go ahead and change this to negative 1/2 x squared cosine 2x plus 1/2. Well, let's go plus, because this negative and negative make a positive. This 1/2 cancels out with that 2. So we really have x cosine 2x dx. Now x cosine 2x looks like I'm going to have to do another integration by parts. Wow. So this problem turned out to be more fun than I thought it was going to be. So let's go ahead and do the integration by parts for this one here. All right, so we've got u in this case is going to be x. So that makes du dx. And dv is going to be cosine 2x, which makes v 1/2 sine 2x, right? Okay, so now we've got to dv du this, or we got to ultraviolet voodoo this guy. So ultraviolet voodoo 1/2 sine 2x times du, which is dx. All right, well at least that one came down. You're not going to like this, what I'm about to say. Sometimes this thing here, this last one, sometimes it's possible for that one not to reduce again, and you have to do integration of parts again. Or what happens sometimes is that one ends up looking exactly like what you started with, and then in that fact it's actually easier than it sounds. But maybe we'll come up with one that comes up like that sometime. Anyway, let's go and finish this guy off here. So we're going to get negative 1/2 x squared cosine 2x plus 1/2 x sine 2x minus 1/2. The integral of sine 2x is going to be, we need a 2 and a 1/2 out there. So we're going to have 1/2 negative cosine 2x. That's the integral of this part. I brought that out. That's what that is there. Plus c. All right, I'm going to clean that up for those of you that want me to clean it up here. Cosine 2x plus 1/2 x sine 2x plus 1/4 cosine 2x plus c. Isn't that some beautiful mathematics there? That's what I say anyway. It's beautiful. All right. Let's do one more here. I think the bell's going to ring on me here. So if it rings in the background, hey, it rings in the background. All right. So we've got x squared ln x. Liat, right? Liat. What's coming first, though? What should u be in this case? You think it might be x squared, but remember, logs are the first thing you're going to use for your u. So u in this case is ln x, which makes du 1 over x dx. So dv is going to be x squared dx, and v is going to be 1/3 x cubed. All right, so now we're going to ultraviolet voodoo it. So ultraviolet voodoo du 1 over x dx. All right, so then we're going to get now here's the thing that I want to remind you is that we have limits of integration here. So we're going to take care of those at the end. So let's go and we're going to do all this stuff, and then we're going to take care of the stuff at the end here, okay? So this x is going to cross out with that one and give me squared. So ln x, we got, 1/3 x cubed ln x. I just like to put that in the front. Minus 1/3 integral of x squared dx, which is 1/3 x cubed ln x minus 1. Let's see, it's going to give me an x cubed, right? Divided by 3, which is going to give me a 9 here. Now, normally I'd put a plus c, but instead we're going to evaluate that from 1 to e. Okay, the whole thing. Those were our limits of integration. All right, so then we're going to get, we're going to plug the e in, 1/3 e cubed. Ln of e is just 1, so we'll leave that there. Look, I told you it was going to happen, didn't I? Okay, 1/9 e cubed minus ln of 1, when I plug the 1 in, is just going to give me 0. And then I'm going to have negative 1/9 because I'm going to have 1 cubed, and 1 cubed is just 1. Okay, and I can actually simplify this down a bit if I wanted to, but you know what? I don't want to, so just leave it like that. But if you really wanted to, this is going to be, let's see, 3e cubed over 9 minus e cubed over 9 plus 1/9, which is 2e cubed plus 1 over 9. If you really, 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 really wanted to simplify it down. Okay. I got one more here for you. This, again, this is not completing the square, but I thought I'd throw it in there because it's an interesting problem. So here you're like, what do I do? What do I do? There's something I could do. Well, this one's kind of a tricky one, but if you can, we're going to complete the square. All right, so here's what we're going to do. Complete the square. We're going to divide by 2 and square it. So we're going to add 4 and subtract 4. So that's going to give me x plus 2 squared plus 4. All right, so I'm going to get the integral of 1 over x plus 2 squared plus 4 dx. And notice that is an inverse tangent. Inverse tangent where u equals x plus 2. All right? And du is just going to be, dx there. So we really got an inverse tangent, arctangent. So the integral of this is arctan. Oh, well, hold on. A is equal to 2. Forgot to put that there. A is equal to 2, right? Right, I get that from here. A is equal to 2. So I'm going to get 1/2 arctan of x plus 2 over 2 plus c. All right, there's my answer. So again, not an integration by parts, but I throw that in because it was there, and I want to make sure you knew how to do that. Okay. All right. So there you go, guys. The second part of my integration by parts video. Catch you later. Bye.